Good morning, Valanda. I am Dr. Ramya Swetha. Today our topic is Electro Osmosis. Coming to the Electro Osmosis, what we have to understand as a part of ground improvement techniques, it is comes under hydraulic modification. In hydraulic modification, we have to understand what are the strategies are required for that thing, for the particular construction, based on the which type of project it is and what type of soil condition that region is it has. So these are all the parameters which we have to understand for modification of any kind of the soil, whether it is in improvement point of view, whether it is in replacement point of view. We have to understand these parameters. So in all these parameters, once we understand the soil condition as per the requirement of the project and the project site conditions, once we understand all the characteristics, then we are going to adopt based on the choice. So based on the choice, which method is adoptable for this also we understand in our previous classes. Now in this dewatering technique, this is another dewatering techniques where we are used. What are the various principles involved in these electroosmosis or applications, advantages, all these things now we are going to discuss in this lecture. So in this, the first thing we have to understand is what is meant by electroosmosis. Electroosmosis, it is a specialized dewatering technique. It is a dewatering technique. So in this, the electro tells. So in anything, the name itself tells something for us. So here also the electro is tells us something, that is nothing but we are going to use electrical current to remove water from the soils. So electroosmosis is the dewatering technique. The name tells that is nothing but this electrical current which is going to remove our water from the soils. So this technique which we are going to use in our the electroosmosis is used for removing the water from the soil or excess water. Whatever the condition, it depends upon the particular thing. So in this, in particularly fine grained or coarse soils like clay. On which type of soil? So based on the type of soil, we are also going to choose the which method is suitable and which is the best method for that conditions. So based on the conditions and based on the soil parameters as well as the site conditions are also important for choosing the method for dewatering. So in that, particularly for fine grained or coarse soils like clay, where traditional dewatering may be less effective. So already we have some traditional dewatering techniques. We know some traditional dewatering techniques. So in thus dewatering technique methods, that effect is very less in such type, that is nothing but the coarse soils or fine grained soils. We are going to consider these electroosmosis. So this technique is often used in civil engineering as well as environmental remediation projects. So in this, as a civil engineering, we have to understand where the ground improvement is required and how the modification is possible, whether mechanical, hydraulic, whatever it may be. That hydraulic, coming to the hydraulic modification, in that too, that traditional dewatering techniques are not that much effective scenario, we are going to choose this electroosmosis. So this electroosmosis is used for reducing the or removing the water from the soil. So in this, what are the principles are involved in this electroosmosis? Electroosmosis relies on the movement of water through a soil matrix under the influence of an applied electric field. So this electromagnetic is completely depends upon the electric field. The movement of water through a soil matrix under the influence of an electric field. When direct current DC, so when direct current DC is passed between electrodes inserted into the soil. So when a direct current is DC which is passed between electrodes inserted into the soil, water molecules which are polar are attracted to cathode, that is negative electrode, and move through the soil. So this movement helps to reduce the water content in the soil and consolidate it. This is the principle which involved in the electroosmosis to reduce the water content in the soil. So here whenever the DC which is passed between the electrodes which are inserted into the soil, water molecules which are polar are attracted to that cathode and moving through the soil. This whole complete movement helps to reduce the water content which is present in that soil, and also it consolidates. So this principle is involved in the electroosmosis process. So in this, what are some of the components are also involved in this electroosmosis system. So coming to the components of electroosmosis system, the one is electrodes. In that electrodes, what are the various components which are going to involved in this electroosmosis? In these electrodes, anodes, cathodes, placements. So these are the components which are involved in these electrodes. Coming to the anodes, positive electrodes typically made of inert materials like graphite or titanium. So this is also have some inert materials. The positive electrode is nothing but the anode, and the negative electrode is nothing but the cathode. In this negative electrode, usually made of similar inert materials are steel. So this placement, electrodes are strategically placed within the soil to create an effective electric field. So the strategical placement within the soil for getting the effective electric field. So this is the components of the electroosmosis system, that is electrodes, power supply, monitoring equipment. So these are the components. So the first one is electrode. In these electrodes, anode, cathode, and their placement of these to create an effective electrical field. This component electrodes. Now power supply. In this already we discussed the movement from direct current, that is DC, which is provides a continuous direct current to the electrodes. It is this source, this DC source, the power supply provides a continuous direct current to the electrodes. And in component of the power supply, the one more thing which we are going to observe, that is voltage and current control. So this voltage and current controls is must because of the without getting any kind of fluctuations. And this component allows adjustments of the voltage and current to optimize the dewatering process. It is going to optimize the dewatering process for adjustment of the voltage. So fluctuations between voltage. So these are the current, the control of that voltage is important in power supply for one of the important component for the whole process, which is electroosmosis. In this electroosmosis, we are going to use, this is considered as one of the component as power supply. In that DC source and it continuous direct current to the electrodes, and the voltage and current control allows adjustments of the voltage and current to optimize the dewatering process. And the next one is monitoring equipment. This is also one of the important component. Monitoring equipment, voltage meters, current meters, moisture sensors. So in these voltage meters, to monitor the voltage applied across the electrodes. So we are going to monitor the voltage applied across the electrodes. And the next one is current meters, to measure the current flowing through the soil. So these current meters are helpful for measuring the how much current is going to flow through the soil. Flow through the soil. How much is flowing through the soil. The next one is moisture sensor to track the reduction in water content over the time. So how much the excess or how much the required, how much it means the required remove, how much we are going to remove the water content from the soil. Water content from the soil is important. So it depends upon the how much water content is present in that particular soil. So we are going to track, we are going to use sensors for this moisture tracking, how much the reduction in water content over time to time. So from time to time we are applying the DC source continuously and adjusting the voltage and also monitoring these things, and you are going to track once it reached the required moisture content of the soil for the project, the construction work. We are going till that we are going to manage and repeating the same process. For that we are going to track the reduction in water content over the time. So these are the moisture contents. So in this monitoring equipment is also one of the important component. Here we have electrodes and power supply and monitoring equipment. These are the components of an electro osmosis system. Now, the process of electro osmosis. Still we understand what are the various, what are the various components of electro osmosis system and what is the principle involved in this and what is meant by electro osmosis system. Now we are understanding the process of electro osmosis. So in this, first we are going to installation. The first one is the installation, operation and monitoring and adjustments are the process of the electro osmosis. In this, the first thing we are going to installation. So electrode placement, insert the anodes and cathodes into the soil at the predetermined location and depths. So the whole soil, some amount of soil and some surface area of the soil is there. So whenever we want, wherever we are going to do all this process is not the way for getting the optimized results. For getting the better results, we are not going to use all these such types. So for this, we have to require the where we are going to insert these anodes and cathodes into the soil at particular predetermined locations and depths only. So we are going to insert these anodes and cathode based on the predetermined locations and depths. So that is the electrode placement. It is very, very important. We have to understand the electrode placement. So next, power setup. Contact the electrodes to the DC supply. So once where we are going to insert these anodes and cathodes in that soil condition, then only we are going to move on to the next step, that is power setup. In this power setup, connect the electrodes to the DC power supply. The next step is operation. So in this operation, the first one is apply voltage. So switch on to the DP power supply to establish an electric field between the electrodes. So the operation is going to start. The next one is the immediate step. Next process is the water movement. So water molecules move towards the cathode due to the electric field, reducing the soil's water content. So because of the electric field, the water movement towards the cathode, and once it means the particular soil moisture content is going to reduced, and soil the ratio of the water how much the water percentage is going to reduce because of this effect. The next one, then in the process, collection and removal. So water collects near the cathode and can be removed using the pumps or drainage system. It depends. So once we are going to collect the excess water, how we are going to remove, it depends upon the site condition as well as the where the location of the site is also. Sometimes we may send into the drainage systems. We are going to provide drainage systems for the after the collection of the water, and we are going to send into through the drainage, and in sometimes we are going to pumping the system. So which is adaptable for this electro-osmosis process? It is depends upon the site condition of the required project and how the construction site is allows the excess water and the collected water to go where it is going to go. So these are all the parameters which we are going to understand in our collection process as a part of this electro osmosis. The next process is monitoring and adjustments. In this monitoring and adjustment, monitor parameters, regularly check the voltage, current and moisture levels. So this is one of the important thing. Because of the moisture levels are reached the required, we are going to stop this process. And coming to this, regular check voltage for getting the better results, and this voltage control is very, very important for the passage of the current. So the voltage and the current and moisture levels checking is very, very important. These are the major parameters which we are going to check regularly, and monitoring is required, that is voltage, current and the moisture level of from the after the process is started. And whenever we are monitoring, it requires any kind of adjustments for these three. The adjustments are also important, and we are going to adjust whenever it is required, and whenever it needs, we are going to adjust and needed to the optimize the dewatering process. Otherwise, we are going to lose this optimization. So it will get, but it took some other path. It took some time. So it is optimized whenever we are monitoring the parameters like these three parameters: voltage, current and the moisturing levels, then and adjustments according to that, then only we will reach this optimization of the dewatering process. So like this, we have to understand the process of the electro osmosis. And coming to the advantages of the electro osmosis, the one is effective for fine grained soils. Why for fine grained soils? So it is particularly useful for dewatering clays and silts where traditional methods are less effective. So we have n different number of traditional methods and different number of traditional methods. So we are using n different number of traditional methods. But even though for these clays and silts is useful, it is effective. It is effective. This electro osmosis process is effective, and the effect of these traditional methods is going to less. Then particular case, this is the advantage of the electro osmosis. We have to adopt the electro osmosis process for fine grained soils. And the next one is controlled process. It is totally controlled and all the parameters are in under control, and we have to adjust, and we are going to monitoring and level by level we are going to monitoring. There is a chance to monitoring So, and allows precise control over the dewatering process by adjusting the electrical parameters. So, we are going to adjust the voltage and going to the and also the current, as well as we are monitoring the how much whenever something is going to the insert in that, we are getting some result, that is less moisture content of the soil and remove the water from the soil. All these is happening, and this overall control of these and the adjustments of these parameters is very very important, and the adjustments and these process comes under this control process. This is the one of the major advantage whenever we are using this electroosmosis for reducing the water content to the soil. And the next one is the minimal soil disturbance. Coming to the some of the traditional techniques, we may get soil disturbances may more in some situations according to the where the site it is, site investigations, soil types also. That minimal soil disturbance is also one of the major advantage of the electro osmosis. So in these minimal soil disturbances does not require extensive mechanical intervention, thus preserving soil structure. So this is the one of the important advantages of the electro osmosis. And the next one is reduced water content. Significantly lower water content, increasing the soil stability as well as the bearing capacity. So the bearing capacity of the soil is very very important for structural design point of view. We are going to understand the some underground constructed elements. It is very very helpful. So this significance lower water content, increasing the soil stability as well as the soil bearing capacity. So these are all the advantages of the electro osmosis. Now some of the advantages, and next one is the limitations of electro osmosis. What are the limitations till now or disadvantages, whatever it may be? We are going to limited. Beyond that, we are going to conduct. We are now unable to conduct. We are not going to allow conduct this electro osmosis. The one is energy consumption, that is requires a continuous power supply. In all the situations, in throughout India or throughout the world, whenever the site is there, so the continuous power supply may not be possible in all the conditions. Based on the soil conditions, based on the locality. So these practical things we have to understand. So based on the practical issues, it may not possible. So the requires a continuous current supply only gives the optimization of the dewatering for the electro osmosis. So that may, in that particular scenario, it may not possible in all the conditions as a practical issue. So that is the one of the limitations which we have understand and which we have to adopt at the time of considering this method. We have to think for the as a energy consumption point of view also, and the continuous power supply of that particular locality is also plays a role for adopting this electro osmosis for dewatering the soil. So in this energy consumption, the continuous, if you want this electro osmosis, the continuous power supply, which may lead to costly and energy intensive. So instead of this, if the possibility is there, the traditional dewatering technique we may conduct, it may get results, maybe less cost. It depends upon the which type of the project and which, on which region. based on the that particular locality, soil conditions also plays a vital role for adopting this electro osmosis. This is the one of the limitation for adopting the electro osmosis for dewatering technique. And the next one is electrode corrosion. Electro-corrosion. In this, electrode may corrode over time, requiring maintenance or replacement. So, whenever we are using these electrodes, time being, after some time, it requires maintenance, or in sometimes it is also is going to be replaced. It depends upon the soil conditions of that locality and how much, where the dewatering technique we are going to implement in that, where the way on which place we are going to, based on the position we are going to insert all these electrodes, that position where it lies, that whether it is maybe on the ground, or how much depth of the from the ground level the particular inserting point. So we are going to insert, and we are going to identify those things. So the position, so where placement, it is depends upon the electrode placements. So into the soil where we are going to for the predetermined locations and the depth based on the location already we allocated some place. So in that particular also depends the scenario. So it may depends upon that. Sometimes in some of the scenarios, some of the situations, we are going to maintenance of this electrode may require. In sometimes in some of the cases, replacement is also we have to consider. So this is also one of the limitation for electro osmosis for conducting the dewatering. And the next one is soil chemistry. Coming to the soil chemistry, effectiveness can be influenced by soil chemistry and the presence of the contaminants. So some of the situations the electrodes may, whenever we are passing these electrodes and also all these things, it is influenced sometimes in soil chemistry also. So it may differ the soil chemistry what we require. So that is also we have to check the properties of the soil, whether it is this electro osmosis technique is suitable or not. For once we conduct this electro osmosis, also how the change of the soil chemistry, it is not good for the project. So that is also we have to understand in, and the presence of contaminants are also important for applying electro osmosis. This is also one of the limitation. The next one is limited scale. More suitable for smaller localized applications rather than large scale dewatering project. So this is more suitable for smaller localized application rather than the large scale dewatering techniques. So this is the one of the major limitation for large scale dewatering projects. We are not going to suggest, we are not going to use this electro osmosis dewatering technique. This is also one of the limitation, and it is going to confined for smaller and localized applications only. The next one is applications of electro osmosis. So where we are going to apply all these electro osmosis. The one is construction sites, dewatering of the fine grained soils to stabilize foundations as well as the excavation. That is one of the application. We as a civil engineers, we are going to understand the dewatering for fine grained soils to stabilize foundations and also excavation. The next one is soil slope stabilization. So reducing water content in slopes to prevent landslides and erosion. So reducing water content in slopes to prevent landslides and erosion. And next one is the environmental remediation. So, dewatering contaminated sites to facilitate cleanup and soil treatment. So, in this environmental, we have to understand these contaminated sites to facilitate cleanup and soil treatment purpose. All this is the one of the application of the electro osmosis. Tunneling project. So, managing groundwater inflow in tunnels driven through clayey soils. So, this is the one of the major application of the electro osmosis. In this, how the electro osmosis system is going to design. So, how we are going to design this electro osmosis system? Consider construction site with a high water table and clayey soil requiring stabilization for foundation work. This is the condition which we have. So, construction site with high water table and clayey soil requiring stabilization for foundation work. So, what are the steps which are going to involved as a part of electro osmosis system design? The first one is site assessment. The first one is the site assessment. Perform all soil tests to determine soil type, permeability and water content. So, first thing we have to understand the soil properties. So, for that we have to conduct all the basic tests for understanding the soil condition, that is soil type, permeability and water content. The next one is measure the groundwater table levels and flow patterns. So, it is high water table. The construction site is at high water table. That's why we have to measure the groundwater levels and flow patterns for better understanding about the site. So, we are going to assess the site, perform all soil tests and understanding the groundwater table and flow patterns. This is the one of the thing we have to understand the site assessment. The first one is we have to understand the site assessment for water table levels and their patterns and the soil conditions. And the next one is system design. So, in system design, electrode placement and power supply. So, electrode placement and power supply we have to understand for the system design. So, in this electrode placement, design a grid of electrodes with anodes and cathodes placed alternatively at appropriate intervals. At least example 2 to 3 meters apart. So, we have to going to design a grid of electrodes with anodes and cathodes placed alternatively at appropriate intervals. And the next one is power supply. Select a DC power source with adjustable voltage and current settings. For example, 12 to 24 volts and 10 to 20 amperes. So, this power supply setup and electrode placement in comes under the system design. So, in electro osmosis system design, the first one is site assessment. It comes under the how much the groundwater is available and what are the levels and what are the patterns and also the soil conditions we are going to understand. The next in this design process, the next step is system design. So, based on the where we are going to place these electrode placement and power supply. The next third one is the installation. The next step is installation. So, insert electrodes to required depth around the area to be dewatered. So, how much dewater area is there? Based on that area, we are going to insert the electrodes for the required depth. So, connect electrodes to the power supply using insulated cables. So, using cables, we are going to connect the electrodes to power supply. This is comes under the installation. The next one is operation and monitoring. So, we are all done. Now we know the soil conditions and water table levels and also where the placing of the electrodes and anodes, cathodes, where and we are going to insert the required depth and connected all the electrodes to the power supply using the insulated cables, and everything installation is done. Now we are going to do the operation. So now we start with operation and monitoring. So this is the next step in the design process of electro osmosis. In this, the switch on the power supply and gradually increase the voltage to initiate water movement. So the first thing is the water movement is required. So for this, as we are going to switch on the power supply and gradually increase the voltage to initiate water movement and regularly monitor the voltage, current and soil moisture levels. Once the process is start, this is the comes under operations step. The next step is we are going to monitoring. So the voltage and current, soil moisture level using various things, that is moisture sensors, and any adjustments is required, we are going to adjust these voltage and current. So all these electrical adjustments are needed to optimize water removal. So these adjustments are as needed to optimize water level. The next one is water collection and remove. It depends. So here use some pipes or drainage trenches because of the high water table and clayey soils are there. So it depends upon the pumps or drainage trenches to collect and remove water accumulated near the cathodes. So how much near the cathodes the water is going to be accumulated. So whatever the accumulated water is there, we are going to collect that water and we are going to remove from that soil and remove from that site also. So how we are going to collect this? Use some pipes or drainage trenches to collect and remove water accumulated near cathodes. So these are all the steps which we are going to understand. So based on these kind of example, we may low water level and sandy soil and different kind of situations we are going to analyze. The first thing we are going to analyze the site assessment, system design, installation, operation and monitoring, water collection and removal. These are the major steps, procedure which we follow for this electro osmosis design for removing the excess water. In overall conclusion, electro osmosis is an effective dewatering technique for fine-grained soils, offering precise control and minimal disturbance. Precise control and minimum disturbance. By carefully designing and monitoring an electro osmosis system, it is possible to achieve significant reductions in soil water content for enhancing the soil stability and supporting the safe construction practices. So for this is the overall view of the electro osmosis. So based on that, we have to understand the electro osmosis for dewatering. Whatever we are removing the water from the soil. So using these web references, these are some of the web references which we follow for better understanding these ground improvement techniques. Thank you. We will see in our next class.
Like, share and subscribe. Hit the bell icon for more updates.